right, class, welcome back to Natural Intelligence, the blueprint for AI. Tonight, we're going to be discussing lesson 7, the query function, where we'll discuss retrieval practice, space repetition, and chain of thought. Now, the generation loop showed the errors driving learning, but creating an error signal once isn't enough. Even though we try something and we get it incorrect, we get an error signal, our brain tries to update, but that's not enough to really cement learning. The brain needs to retrieve information repeatedly to strengthen the neural pathway. So it's not just one error signal. We need a repetitive round of error signals so that we can learn and be able to call on demand or recall on demand that information. Now, we'll talk about again a little bit how this blends into our previous lesson. Just quick recap here from lesson 6, the compression algorithm, where we learned about our brain learning from prediction errors. We talked about the loss function as well as building a generation loop. Please do go back, watch that video if you want a recap and just a refresher on the compression algorithm and how the brain actually predicts errors or makes a prediction and then compares its prediction output to the reality or the accurate answer, and therefore signaling an incorrection, right? Or some type of error there. And that's when the brain actually goes into high gear and starts to learn when you actually make mistakes or when you get something incorrect. So it's actually not a bad thing for you to make mistakes. The more mistakes you make and the more opportunities you give your brain to compare and update the results as you do that in a repetitive nature or cycle, that's when you actually deepen those neural pathways. And so tonight we're going to carry that on forward to now with the query function, where we'll talk about strengthening that neural pathway through retrieval. And in particularly, the mechanism we'll talk about is retrieval practice and spacing effect. So this would be where we'll be pulling information out of memory, because this is an important part, because this is, if we're pulling information out and we're doing it at an expanded interval, this will rewire that neural pathway. Because the problem is that when you're learning, you tend to think that just by storing information, you're learning information. But in fact, it's not until you start to retrieve. So when we reread or highlight information, we're not doing as much as we could as if we were reading as well as testing ourselves, quizzing ourselves, and then doing a comparison or some type of reflection on what we got correct and what we got incorrect. This is where storage is not so important if there's not real retrieval there. Now, what does that look like? So here, a pretty good visualization here, where again you're quizzing yourself. Maybe you have some index cards where you're going to try to guess or try to predict what the answer is after you've done some studying. And you'll find out, okay, all right, you'll flip that card over and either you got the correct answer or you did not. And over the space repetition of a few days or maybe a few weeks, you do this on repeat. And the more times you do it, you're actually building that neural pathway. You're strengthening the neural pathway, I should say. And we'll talk about again now how that query function works specifically, because the query loop is where we really go into asking ourselves, what do I know about a particular topic? And this can be any topic, and maybe it could be recall from a previous conversation you had with someone. But what you're thinking about here, where you're querying, you're searching, you're basically asking yourself the question, what do you know? And then once you have that question posed to yourself, you're then go into retrieval phase. And this is where you get to pull that answer from memory. And it should take some effort, because if it's too easy, you're not actually learning anything. So you do want this to be a little challenging, right? But just like if you're in the gym training, you don't want to put too much weight on that bar, but you want to put just enough weight on the bar that you have a good level or good amount of resistance so that you can again develop the muscle. And this is the same thing that we're doing in this retrieval phase of the query loop. We're developing the pathway, the neural pathway of learning here. And then next up, you're going to check your accuracy when you're verifying, and then you're going to space this out. You're not just going to do it one time. You're not going to the gym one time and saying, "Woo, I got a nice little burn. I'm feeling swole." Okay, no, that's not enough. You're going to have to do it over the course of 6 weeks, 16 weeks, 24 weeks, 52 weeks, right? And then why this spacing works is because you have this mass practice of cramming, repeating 10 times in one session, and you feel like you're learning a lot because everything's pretty much stored and recalled from the short-term memory. But after a few days, right, you realize, wait a minute, I don't remember half of those things that I was getting right. I remember myself getting them correct on that day while I was cramming, but here comes the day of the test, and all of a sudden I go blank. Well, the reason is because you didn't do any spaced retrieval. You didn't try to retrieve at 1 day, 3 days, 7 day, 30 days. And if you did not make it feel harder, right, then you're not really deepening that neural pathway so that the knowledge and the information sits there and is ready for you to call on demand. And so this spacing effect was discovered by Cepeda in 2006. And essentially it just talked about distributing practice reduces 10 to 30% better than retention when you're using masked or crammed practice. And I think a lot of us knew this. This is pretty intuitive when you really think about, all right, last time you tried to cram for something last minute, you realize that maybe if you're taking that exam right then, you may be able to retrieve a lot of information. But as you can see here in the chart, when you're cramming, right, you take all that information in on day one, and as day 2, 3, 4, 5, if your exam is on day 7 or beyond, right, you have already forgotten a large chunk of that intense cramming that you were doing. Compare that to spaced retrieval, right? And you can look at the two here, juxtaposition of, the cramming versus the spaced retrieval. You're going to get a retrieval, what they call a retrieval boost every time you go back and restudy or review that information or recall that information. This over time ends up being a high retention. You can see we have a little dip there, but then after that second day, we get a jolt, we get a boost because we're now doing some more practice. And then a couple of days go by again, we practice some more, and we get another boost. And that continues on and continuum until you have a nice steady level high retention, and that sticks with you a much longer time. And this is how memory works and also learning. Now, the bridge here, when we're talking about the human versus the AI, talk about AI inference and chain of thought. Now, with human retrieval practice, the process is posing a question and retrieving from memory. Whereas on AI, the process is going to look a little bit more like receiving a prompt and then generating a token by token, which is essentially predicting the next word or phrase, or more accurately, the next token in a given sequence. That is the process for retrieval in AI or artificial intelligence models. Now, strengthening looks a little bit different because in human, we're going to have a retrieval. Each retrieval phase, it's going to reinforce the pathway. Well, strengthening in AI looks a little bit more like chain of thought, decomposes complex queries. And when we talk about chain of thought, we're essentially trying to think our way through a difficult problem. And that's what the AI is doing. The AI model is essentially thinking through step by step a particular problem, and it's breaking it down, it's breaking down those very complex queries by going step by step. And by doing that, it's strengthening its ability to predict the next token very accurately. Now, on the human side, optimization is when spacing maximizes long-term retention. The optimization piece for the AI is few shot prompting gives retrieval scaffolds. And when we talk about few shot prompting, we're talking about giving that prompt or that context window maybe a few examples, right? You'll say, look for this, or I'm trying to create this, look at this particular attachment or this image or this document as an example. And that's what we call few shot prompting. Now, the weaknesses on the human side is that our humans, we favor easy rereading, right? We think that just by reviewing the same material and only reviewing it, not testing ourselves on it, not uh, measuring or comparing our ability to recall the information, speaking about it, giving a talk on it, or telling someone about it, or even just writing it down from memory. Those are ways to sort of engage this particular axiom. But when we don't do things like that and we leave it just as simple as I'm just going to review my notes and look over them 10 different times throughout the week, we think that that's actually helping us learn, where it's just storage but no retrieval. And the weakness on the AI side is where, again, that type of loss of context or loss of repetition of seeing some material that's relative, that's going to produce hallucinations because we don't have a grounded retrieval. For example, in uh, excuse me, retrieval augmented generation, or RAG, right? So this axiom here, where we have both brains, the AI, the human brains and the AI models retrieve knowledge through structured queries, the quality of the query determines the quality of the output. Now, here's an example just to, again, put it in visualization piece. Again, the human mind, we're focusing primarily in natural intelligence. We're thinking about memory retrieval, whereas in artificial intelligence, we're thinking about AI inference, or in other words, the ability to predict and produce the correct output in a token. All right, so a little bit different here, a very similar process, different outcomes, but essentially mirrored or patterned after artificial after the natural. Now, how can we breach this protocol? What are some strategies to get around this? So let's look at the space retrieval strategies. Number one being retrieve before you review. So before rereading, close the source and write what you remember. So retrieval first, then review second. All right. You're thinking of something, you study something, and then write it down. Try to write it down, recall it from memory. And this is a way for you to retrieve before you review, just to test yourself to see if you've even taken in what you just ingested, if you've actually let it sit into your mind. Number two is expanding the intervals. So again, starting at day one, then 3 days, then 7 days, for example, then maybe up to 30. Each gap is going to make it a little bit harder for you to retrieve or recall that information. And this is actually going to be a way to have a stronger trace. This is going to force your brain to work a little bit because you're spacing out the retrievals. And those interviews, again, make it a little bit harder for your brain, but that actually has a benefit in the end because now you're making that neural pathway stronger. Same scenario in the gym, right? The more we make our muscles work, the harder or stronger they get. And that's what we want in the long run. Now, number three is interleave your queries. So mixing in topics in each retrieval session, interleaving forces discrimination, which deepens encoding. And number four is chain your thinking, breaking down those complex retrievals into sequential steps. Each step scaffolds the next, just like chain of thought. And here we have, again, another example, very similar chart to the one we saw before, the memory retention timeline and retrieval boost. So we can see over the next 30 days or so of retrieval boosts at these given points, or these sort of checkpoints. But each interval, again, gives us an opportunity for that brain to work a little bit harder. And after the course of 30 days or so, we have this nice hunkin' chunkin' swole brain of ourselves, right? That we got here, where we're able to, again, retrieve and recall information very easily. Again, look at that 95% retention rate by this interval or space repetition strategy. Now, let's take that into being applicable into something that we can build. So let's focus on now creating a spaced retrieval schedule, because again, we don't want to just practice one time. We want to space this out so that we can, again, get those boosts in that ultimate high level of retention that is sustainable over time. So we're going to define what to retrieve, set expanding intervals, interleave top topics, and then build a chain of thought structure for complex material. Let's look at the requirements for each. My architects, you guys are going to be designing a retrieval schedule. You'll have inventory, which will list the key concepts you need to retain, break complex topics into retrievable chunks. Then you'll set up your schedule, either day 1, day 3, day 7, day 14. For example, you can use this schedule. There are no set timelines or interval timelines. You can make them up however you want, but just try to spread them out a little bit. And then you have the interleaving where you're mixing in topics per session. We'll throw in some chaining here again, where we'll be decomposing complex topics, breaking them down step by step. And then we'll do a tracking phase where we'll mark each retrieval correct or advanced interval or error, right? So we'll be able to tell if we got the answer correct or if we got the answer incorrect, which will be an error, and then would have to reset to a shorter interval. So the way you can think of this, if you are able to space out your reps or space out your retrieval schedule from 3 to 7 days, so that's a 4-day gap, and you're still getting the correct answers. Well, now advance the interval. Now go for maybe a 7-day gap between retrievals until you get an error. And then when you get an error or when you start to get answers incorrect, that's when you need to reset or essentially drop back down from going from a 7-day gap or a 10-day gap, drop back down to a 5 or 4 or 6-day gap. Just again, don't stress your brain too much. Again, I'll use the analogy of being in the gym, right? You try to hit that, 225 for 10 reps or so. You don't quite get to number 10, maybe drop down the weight just a little bit and then try to go for reps of, 12 to 14 or something like that at that lower weight until you develop the strength to get through 225 for 10 plus times. That's for all my gym bros out there. All right. Now, my builder tasks, what you guys are doing, you're going to be space retrieval system prompting, right? So then generating a retrieval questions, or just generate retrieval questions at expanding intervals. Again, using intervals that are increasing over the term. So 1 to 3, 2-day gap, 3 to 7, 4-day gap, 7 to 14, 7-day gap, and then 14 to 30, a 16-day gap there. And again, at each one of those intervals, you are testing, you are tracking where you got incorrect, because you need to know at which interval was too much for you. Number 2, you have the use of chain of thought, where we'll be breaking down complex retrievals. Then you'll track that accuracy, again, comparing your 2-day gap in intervals versus your 7-day gap in interval. Compare where you started to forget a lot of things. And then finally, interleaving those topics per session, varying question types, recall, explain, and apply. All right, so let's just recap and talk about what you need to remember from this lesson. Number 1, memory is retrieval, not storage. Okay, so your memory does not do you any service, or you do not do your memory any service when you're only focusing on the input and storage. You need to focus equally on retrieval. The spacing effect, retrieval at expanding intervals. So again, using 1-day, 3-day, 7-day intervals, for example. Again, there's not a set term here or set duration for the intervals, but space them out, and you can customize this depending on how well your performance is doing, or maybe how poorly your performance is doing. AI inference, right? We're essentially relaying this to retrieval from weights or back propagation. You have the chain of thought or step-by-step retrieval. And those two are bridges to the AI and how AI is in using memory or optimizing its memory. Number 4 thing to remember, interleaving topics forces discrimination between similar concepts, building stronger and more distinct memories. So again, we're just talking about having some diversity of the topics you're studying or you're trying to remember. That's going to, again, make your brain focus in on something that is a little bit different, but similar enough that you're focusing. Okay. But it's almost like, okay, you're going to the gym. Maybe you do a squat and then maybe you also do a leg press, different exercises, but similar concepts. They're both still working your lower body, glutes and uh, hamstring, excuse me. Number 5, you got the stack here. Just recalling the full stack that we're at number 7 here, or excuse me, number 6 of our stack. We have our salience, our chunking, our dual coding, schema graph, generation loop, and then now the space retrieval. In the next lesson, which will be the last lesson for natural intelligence 101 at least, we will be discussing the save protocol, where forgetting, consolidation, fine tuning, and weight optimization will be the topics. All right. Thank you so much for your time. We're going to wrap things up now. If you enjoyed the video, please let me know by subscribing and sharing. If there's anything that you want me to break down for you in the next lesson, please let me know in the comments. Or if there's anything I can do better to serve you, please do let me know. I appreciate you giving me your time. And until the next time, class is dismissed.